welcome back to ME470 Class 3. We're continuing on with gears. This is in Chapter 13 of Shigley. Let's talk about the layout of a basic gear. Okay, so here is figure 13.9, but I've kind of made this animation to walk through here and try to help you lay it out yourself, right? First off, over here, we want to give a name for the two parts right here. So we're going to call the smaller of the two gears the pinion. Quite often the pinion will be driving, and this is not a very creative one, the gear. Okay, I would actually maybe, if I were to be, to make a decision here, I would call it the bull. Maybe you have the pinion in the bull. Sometimes we call it a bull gear, right? But here they just gave it the generic gear, right? So in this context, one is the pinion and one's the gear. The smaller of the two is the pinion. Quite often, the pinion drives the gear, but that's really only in a gear reducer, right? If you had a gear that was meant to actually increase the speed of something, the bigger of the two would be driving the smaller one, right? But a lot of times we do have reduction gears. We do reduce the speed. That was probably the majority of the time in gears. That's what's happening. So the pinion is the smaller of the two, right? So if I were to go to this right here, right? This right here would be the pinion, and this right here would be the gear between them. Okay, so with that, we often will give that as a subscript to all of the dimensions and things that we deal with. Now, the most important circle that we deal with is going to be the pitch circle. And if you look closely at this, that would be the diameters of the circles if there were no gear teeth. Let's think of this as just being like these two cylinders that had like really good friction between them. So they were just like maybe these rubber discs, and because the really good friction between them, they're able to force the other gear to the other disc to spin, right? So this one spins, and because of the friction, it allows this. So that would be the diameter of those two right there, if there were no gears involved. So there's this little point between where they are tangent to each other, where they touch. And there's this line that you draw right through that little point. You see that little star right there. That's the pitch point. And there's this line we call the line of action. And that line of action forms this angle with the one that's the line that's tangent right here. So there's a line tangent. You see this AB right here. But there's a line called the line of action that runs through here. And that's the line along which the forces of one gear pushing onto another align, right? You'll note that there's this perpendicular distance from the center of the pinion to that line of action, and then there's also one from the center of the gear to this line of action, and we call those the base circle, right? And that base circle is used not only in this context, but also it is the main line about which the geometry of the shape of the tooth is determined, and we'll see that here in a second, hopefully. And that shape, most often for gears, the most common one is called an involute, and it's actually sort of a geometric shape. It is in most contexts it's about gears, but you could also make the case that it's just a geometry type of shape. And it's not the only kind of tooth shape that is possible, but it's the most common one, and it's the one that we will consider only here. And then the top of the teeth, right, as we had mentioned in the previous video, there's this dimension called the addendum, and the addendum plus the plus the pitch circle. The addendum plus the pitch circle is equal to the addendum circle right there, where you'll see this labeled right there, these addendum circles. And then we also have the root of the teeth right there, right? And you'll see that's the dedendum circle, right? So what we do is we subtract from the pitch circle the dedendum, and that becomes the dedendum circle. Okay, so but by the way, we actually subtract 2 times the dedendum, right? Because that's actually like a radius right there, right? So we want to have the pitch circle, we subtract 2 dedendums, it becomes the dedendum circle. If we have the pitch circle and we add 2 addendums, we get the addendum circle, right? And you'll see that the addendum is 1.25 divided by pitch, whereas the dedendum is 1.25 divided by pitch, where the addendum is 1 over pitch. And then we can also find the tooth spacing right here by getting the circular pitch right here, where it's just called P, pi divided by capital P. And you can see there's the circular pitch that's on there. Okay. So when doing this, it's best, I think, to do it by hand, right? To draw this out by hand so we can better understand this pressure. All right, these circles are here. So we have the pressure line of action. First off, I think I have drawn out already. I've calculated out already the as part of this right here. So this is the pitch circle, and you can see that's the pitch circle here. I've already found the base circle here and the base circle there. So if let's say that I think I might have drawn, yeah, I kind of did. So what we want to do is have this, and if I had a square right here, maybe I'll try that right now. Something there. Draw a line right here through there, and if this thing is rotating, I'm going to say this the right way. I think I'm going to say it the right way. Yeah, okay. Let's say this is rotating this way, and this is the pinion. We're going to, if we look at it, we can look at where that tooth connects right there, right? So if it's moving this way, this side of the face is going to be pushing down and touching that side. And you can see that it doesn't touch here. It touches right there, right? So, and it should right through this line. And this it's going to be perpendicular to the profile right there. You can see the profile right there is perpendicular to this line of action. So right here is the pitch point, but right there is where the contact of the teeth are going to be, right? So this right here is the line of action, and right here is going to be our pressure angle. And the most common pressure angle that you'll find is 20 degrees. There's also 22 degrees is common, and an old one that happens to still be around 14.5 degrees. I think there's also a 21, but there's not that many other ones, other pressure angles. So we'll look through catalogs and you'll get familiar with that. But that's a categorize right there. So this is the line of action, also called the pressure line right here. Other things that we want to consider when we're laying this out, right? We would take, well, first off, we would find the pinion diameter right here. We'll find the pinion diameter by taking the number of pinion teeth and dividing it by the capital P, the pitch, right? And that determines that diameter right here. We also, we could find the base circle right here, and we'll write D, and then we go B, and then P. Okay, so that little p, that's for the pinion. So this is the base circle diameter right here. That's found by taking the pitch diameter and multiplying it by the cosine of phi. And you go, well, how is that true right here? Okay, wait, I think I messed up. Darn. Okay, so I did mess up. When I was drawing this line, I made a mistake. I apologize. The point of this line, this is important here, is we take that pitch point and we draw it right here. Okay, so I messed up. So I apologize for that. There, right there, is, you'll see that there's a base circle right here. There's a base circle here, and there's a base circle there. And that should go right through there, all right? And so it needs to be tangent to each of these base circles and running through the pitch point. Okay, so that's the real critical thing. Let me move that a little bit. And you'll see that right here we have a perpendicular line that runs right through there. And the same thing here. Let me see if I can get that a little bit more perpendicular. Right in there. Okay, so that's perpendicular. Right, sorry about that. Yeah, okay, and so this is that right there is the pressure angle, and this is the line of action. Okay, so I forgot about that. Yes, it needs to be perpendicular to this base circle, and that base circle is found, each of these base circles, right? And so there's two different base circles. There's this one is decided by this right here, and it actually kind of makes a sort of sense that if you were to take this dimension right there, see that dimension? That's the radius right there from the center to that pitch point right here, and you can see that's the hypotenuse of this right triangle right here. So in order to get this radius right here, you would, and this angle right there is the same angle as that, right? So in order to get this radius, you multiply this radius times the cosine of that pressure angle, and that'll give you the radius, which is really the torque arm you can think of, because this is the line of action. This is where the force, that tooth right there is pushing on, this tooth is pushing on that tooth, and it's coming down in that direction. So the line that's perpendicular to it is really the torque arm that you would have, right? You would multiply that force times that distance right there to be able to get what the torque was that's being applied from this right here. And that needs to equal the torque that's going to be over here, right? So the torque transference between this and this is dependent on that distance right here. And in a similar way, let's put it over to the side maybe here. We would have this diameter right here is the gear pitch diameter, and it's going to be the number of gear teeth divided by the diametral pitch. And then we would have, let's place it down over here to get it out of the way. This would be the gear base. Let's see, I think we're going B and then G, right? So the diameter of the base circle for the gear is going to be equal to the pitch diameter of the gear times the cosine right there. So you can see once again right here, here is the there is the pressure angle right here. So here would be the radius of the pitch circle for the gear, and so right here would be the radius of the base circle for the gear. The other thing that you would want to care about in this is the center to center distance. That's like an important thing to figure out when you're going to lay the things out, right? How far apart these gears are going to be, because there can be some amount of you know, if you don't have it exact, the teeth, not as much teeth contact. If you have it too close, they can bind right in there. So that center to center distance is determined by the pitch diameters, right? And so we'll have a C. That's not for clearance, that's for center, right? That's the center distance right there. Maybe make it a capital C. I don't know. Sometimes the book isn't consistent with this. But we have 2P, dP plus dG divided by 2. Pretty simple, right? But it's important when you're laying things out. And when you're trying to do design, that's one of the first things you need to find out is the center to center distance so you can lay out your gearbox. I think that's a good place to break off, and we will continue with this in another video. And that was a 15-minute video. It's probably a better length. Try to be a little more efficient.